Hi everyone! Today we're going to study more examples about equivalence classes. Let's see this example 1. Find the equivalence classes of 0 and 2 for the relation congruence modulo 7. The congruence modulo 7 equivalence relation is defined by this. R equals the ordered pair AB such that A minus B is divided by 7 is an element of integers Z. We will denote the equivalence class of A under the congruence modulo M as this notation. A is enclosed in square brackets and a subscript M is given. Let us now define the equivalence class of 0 for the relation congruence modulo 7. As defined, the elements are S, such that the ordered pair 0S is an element of R. For all S, an element of Z, the integers. Likewise, this equivalence class is defined like this. The elements are S such that 0 minus S over 7 equals K. This K is an element of Z, the integers. For all S, an element of Z. Let us now write the elements of the equivalence class of 0. The first element will be that 0 itself. On the right side of 0, the next element will be 0 plus the modulo 7, and that will be 7. This value 7 plus the modulo 7, we will get 14. 14 plus 7 will be 21. This pattern will continue as we go on with the right side. On the left side of 0, we will have 0 minus 7, so we will get negative 7. This negative 7 minus 7 will get negative 14. Negative 14 minus 7 is negative 21. This pattern shall continue as we go on the left side. So these are the elements of the equivalence class of 0 for the relation congruence modulo 7. Let's go now to equivalence class of 2 for the relation congruence modulo 7. As defined, the elements are S, such that the ordered pair 2S is an element of R. For all S, an element of Z. This is also defined like this. The elements are S such that 2 minus S divided by 7 is equal to K. This K is an element of integers Z. For all S, an element of Z. Let us now write the elements of the equivalence class. The first element is the number 2. The next element on the right side of 2 will be 2 plus the modulo 7, and that will be 9. This 9 plus the modulo 7 will be 16. 16 plus 7 is 23. This pattern shall continue as we go on the right side. On the left side of 2, the first element here will be 2 minus 7, so we get negative 5. Negative 5 minus 7 is negative 12. Negative 12 minus 7 is negative 19. And the pattern continues on the left side. These are now the elements of equivalence class of 0 and equivalence class of 2. Example 2. Find the equivalence classes of 0, 1, 2, 3, and 4 for the relation congruence modulo 5. The equivalence classes are tabulated in the table here. So we have the equivalence classes for 0, 1, 2, 3, and 4 respectively. Let's start with the equivalence class of 0. This is equal to 5 times n, such that n is an element of z, the integers. So the elements of this equivalence class are starting with 0, going to the right. So 0 plus 5 is 5. 5 plus 5 is 10, and so on. On the left side, 0 minus 5 is negative 5. Negative 5 minus 5 is negative 10, and so on. Let's go now to equivalence class of 1. This is equal to the 5n plus 1, such that n is an element of z. So the elements of equivalence class of 1 will be here, starting with that number 1 itself. On the right side of 1 is 1 plus 5 becomes 6. 6 plus 5 is 11, and so on. On the left side of 1, the first element here is 1 minus 5 is negative 4. Negative 4 minus 5 is negative 9. These are now the elements of equivalence class of 1. Let's go to the equivalence class of 2. This is defined as 5n plus 2, such that n is an element of z. The elements of this equivalence class are here, starting with the number 2 itself. So 2 plus 5 is 7. 7 plus 5 is 12, and so on. On the left side of 2, the element is 2 minus 5. That's why this is negative 3. Negative 3 minus 5 is negative 8, and so on. Let's go now to equivalence class of 3. This is defined as 5n plus 3, such that n is an element of z. The elements of this equivalence class of 3 starts with the number 3 itself. 3 plus 5 is 8. Next element, 8 plus 5 is 13, and so on. On the left side of 3, we have 3 minus 5 is negative 2. Negative 2 minus 5 is negative 7, and so on. The equivalence class of 4 is defined as 5n plus 4, such that n is an element of z. This is equal to the first element is the number 4 itself. So 4 plus 5 becomes 9. 9 plus 5 is 14, and so on. On the left side of 4, we have 4 minus 5 is negative 1. Negative 1 minus 5 is negative 6, and so on. So we have here now the elements of the equivalence classes for 0, 1, 2, 3, and 4 respectively. These are the final answers. I hope you learned something from this video. See you again next time.